Homework 1.4, section complex numbers, video 3, homework due May 16, 2020. The previous two videos took a little longer than I wanted, but I felt it was kind of a good idea to review types of numbers before we get into what are actually called complex numbers. Recall that in the previous two videos, we went through the historical development of counting numbers, whole numbers, integers, rational numbers, and real numbers. And at the very end, we attempted to solve an equation, and that equation was x squared equals -1. And when we got down to it, the problem was, what do we do with the square root of -1? Because it's not real. And then somebody finally had the fortitude to say, if you see the square root of -1, change it to I. In other words, they defined the number I to be the answer to the square root of -1. Keeping in mind that it is not a real number. It does not live on the real number line. Excuse me, I have the hiccups. If I remember to do it, I'll actually show you where the number I lives relative to the number line. In fact, I'll show you right now. Do you remember why they chose the letter I to represent a word that means not real? Imaginary. Here's the number line, with 0 in the middle. To the right is 1, 2, and 3. To the left is -1, -2, and -3. So, where does this I live? Well, it doesn't live on the number line because that's not a real number. So where does it live? Well, it's not one space to the left of 0. It's not one space to the right of 0. It is actually one space above 0. What a lot of people never see, and they're usually thankful for it, even though they don't know it, is that there is a whole other number line that goes vertically right through the 0 on the real number line. It looks just like a regular number line, except the numbers on it are imaginary. One space above the number 0 is the number I. Guess what's two spaces above the number 0? 2I. And three spaces, 3I. And then 4I. And if you go down, -I, -2I, -3I, -4I. And if you're starting to think, oh my gosh, you're going to ask me to do graphing and this type of stuff? No, way beyond the scope of this course. Don't get me wrong, there's a very strong and important connection when it comes to engineering and physics, but it's not somewhere that we're going to go in this class. Now, if you happen to be heading in a physics and engineering direction, don't worry, you'll talk about it when the time is right. So what's the next group of numbers? Well, it can't just be the numbers that have eyes on them. Because remember, in this development of numbers, we didn't go to the side and pick up a totally different group of numbers. We took the numbers that we already had and we added to it to get a larger set of numbers. So the next set of numbers is called the complex numbers. There's usually more discussion that would be between real numbers and complex numbers, but because I've already taken up so much time, I'm just going to get right into it. So what are the complex numbers? Well, like the rational numbers, I can't list them all, but I can describe them. The complex numbers are the set of all numbers that look like this. A plus bi, where A and B are real numbers running into my complex plane over here. In other words, you take two real numbers, so any two numbers on the number line, you put one here and you put one there. So for example, 3 plus 4i is complex. And by the way, the word complex here doesn't mean difficult. It means made up of more than one part, like an apartment complex. Excuse me, I got my water here. So any number that looks like a failed attempt to combine a real number and an imaginary number is called a complex number. And it doesn't matter how pretty or ugly the two real numbers are. For example, I could say pi minus the square root of 2i is complex. This is a real number. It's about 3.14. This is a real number. It's irrational, but it's real. In fact, both of these are irrational, so if I take 2 steps backwards, there's no such thing as pi or the square root of 2. But that is a complex number. Now be careful. I mentioned that the complex numbers is not different from the real numbers, it's an extension of it. So what do I mean by that? I mean that every real number is a complex number. Wait a second, you said complex numbers have to look like this. Well, sort of. They have to be able to look like that. For example, give me any real number. Give me any number on the number line. Oh wait, I'm monologuing, not dialoguing. It's not live, so I'll just have to pretend that you're answering me. Let's say you give me the number 13. How can we justify that 13 is a complex number when it doesn't have an imaginary part to it? Because it does. How many i's are attached to this? Literally, none. Because we can write the number 13 as 13 plus 0i, that means that 13 is a complex number. It is complex. Which illustrates that every real number is also complex because its imaginary part is 0. And vice versa, any imaginary number is also complex. For example, 5i, which would be one more space up there, that belongs to the complex numbers. I know it doesn't look like it has the two parts. That's because the first part is missing, because the first part is 0. Because I could write 5i as 0 plus 5i, that means that 5i qualifies as a complex number. You're a complex number if I can make you look like this. Truth is, every number you will ever run into, unless you go way down the engineering path, is a complex number. You usually don't need to know that, but every real number is a complex number because its imaginary part is 0, and vice versa, any imaginary number. And I don't think I actually defined what imaginary numbers are, so if you'll allow me to verbally, they're numbers with eyes on them. So any imaginary number can also be viewed as a complex number because its real part is 0. So the real numbers are inside the complex numbers. The complex numbers are an extension of the real numbers. So that's all a complex number is, anything that looks like this. Oops, my apologies. In the definition of the complex numbers, the set of all things that look like this, where the a and the b are real numbers, you actually have to say what I is. So inside of this, it should also say, and I is the square root of -1. Again, don't try to answer the square root of -1, its answer is I, by definition. So that's all a complex number is. Before I wrap up this video, I want to show you where some of these complex numbers live. Because all the real numbers live on this number line, the real number line. The imaginary numbers live on this imaginary number line. And by the way, this picture won't be part of your homework. This is just me extending the topic. So where do the rest of the numbers live, like 3 plus 4i? Where do you think it would live? Hint, think graphing. Well, here's 3, here's 4i. So 3 plus 4i would be over 3 and up 4i. So that point right there represents the number 3 plus 4i. You might be thinking, no, that's 3 comma 4, that's graphing, and you're not wrong. It's just that if you really want to go down that path about the connection between ordered pairs and complex numbers, stay in math for a long time. And by the time you get past the calculus classes and some of the theoretical classes into your junior or senior year, then you'll start talking more in depth about the connection between the graphing that you know and complex numbers living on this thing that looks like a coordinate plane. All right, so in the next video, we're going to start actually doing some arithmetic with complex numbers, and we'll start making connections to some of the homework problems.